Okay, let me start with thanking Barry and Juan for this wonderful introduction to EPO, and also they have been, sorry, this is a little, that's better? Okay. They have been part of the inspiration to this talk, especially EPO content part. So content is architecture. Enterprise MediaWiki is a chatbot to EPO. Basically, the idea behind the chatbot is to have a drill down tool to content, not to individual property values, as we know from the extension. I want to talk about the fact that EMW is able to minimize mental overhead when we learn and use information or knowledge, how we do high-level and low-level organization of a structured externalization of ideas. We're getting to that. And I'm going to present a couple of EMW design emergence tools when we emerge the optimal design and we manage the data. So quickly about organizational knowledge in general and EMW. You know, we've got tacit knowledge and explicit knowledge. When we externalize it, then we write it down. We write down our knowledge. We can also say we teach it to EMW. This is understanding EMW as a colleague rather than as a simple tool. When we learn it or we use it, we internalize it. So we read it on EMW or we learn it from. And then, of course, we can combine articles and concepts that we read that would be to develop the knowledge further on the on an EMW. Now about minimizing mental overhead. Let's say we're looking for configuring Apache to use SSL on Ubuntu 14.04. Of course, we could read books, right? We could read table of contents, go flick through indexes, and browse through the book, but much better we use Google. And of course, the first article you see is on my hosting platform, DigitalOcean, is how to create whatever. And you see this is spot on, the specific and limited purpose. And that's how the article looks like. It is exactly to the point addressing the problem that I face. So I don't have to spend a lot of mental overhead to figure out where I get what. So there's a new focus. We're talking about how to find things, not where, and also how to use them. So we're talking about a decision support system and not a simple manual tool. Because sometimes if I tell you you can use A or B, that doesn't help you if you don't know what A or B do and what the consequences are and how they integrate and how the context is and so on. So this tool, normally you then call up some colleague and ask them, what about A, what about B? I've got the instructions, but what should I do? That's not enough. So we have to do the right thing for the right reason and do it right. This means we want to avoid the need for socialization, right? We want to have the wiki provide everything, the decision support and the instruction. And we are not writing those articles merely for our colleagues or future employees. We are also writing them for our future selves. You in 3 months is a completely different person than now, because if your brain hasn't spent a lot of time on the subject, you will have no clue what you've been doing. We know that from programming very well. We love each other, we love ourselves. If we do a good job, we hate ourselves the next day, or let's say 2 months ahead if we do a bad job. Now, takes two things. It takes content style, this is the EPO aspect, and it takes a faceted navigation to get there. And the funny thing is, sorry, this was one page before. This is just the same book as Juan and Barry were referring to. On page 45, and this is the only thing I'm going to read off the screen, it says a faceted navigation could easily be created to allow programmers to query an API reference this way. So he's talking about this EPO subject affinities way of getting to content. And then in this footnote, it says, I know of no example of this actually being done. Please let me know if you know of one. And I think it's one of the missions of this conference to exactly address this footnote. So, what is content style EPO? I briefly go into the details. Of course, this book is one of the best technical documentation books I've ever read. On every page, there's about 10 concepts that it takes a night to grind through your head and actually really benefit from him. But when you read something and you get an instruction, can you act on it? You're not learning art for art's sake. You want to act on it. So, first of all, is it apt for you? Is the article to orient and plan? Is it to understand? Is it a sequence of tasks? Or is it a particular task and their procedures? These are 4 completely different types of articles that help you in different ways. And most importantly is the second question. Are you qualified for using it? I'm sure NASA has a lot of wonderful instructions that I would be completely unqualified to use. However, everything is there to run the space station. So, let's say you are apt and qualified. What does it take now? Well, it should conform to a type. It shouldn't mix, overview with detailed procedures. It should be specific and limited to one thing. You want to know how to install SSL on an Apache. You don't want to know about the philosophy behind encryption using asymmetry or whatever. It should be self-contained. If it matches your level of qualification, you should be able to complete the entire task using that article only. It should be on one level. If you have an article explaining to you how to cook pasta, that doesn't mean, it shouldn't contain information how to harvest a field to get the flour to make the pasta. That is a link for farmers or hobby farmers or whatever, and it should be a qualification match. So it shouldn't mix levels of qualifications. And it should be minimalistic. We all are somehow prone to happy engineering. We should not, put syntactic sugar into those articles because they're not useful. Now, let's say you're not qualified or it's not the right article. Then this article needs to establish context. First of all, for you to help to figure out that you are not qualified. Secondly, it should link richly to other content that probably will make you qualified. Sorry, it will use subject affinities, and I'm coming to that, what that exactly means. And the purpose of this establishing context, linking richly, is actually to help you get qualified and or travel the last mile to the right content, to the right type of article. We all know that, we take the first link on Google, the first result, and it's not quite what we need, but we can, travel the last mile, and it's this EPO contents task to help us doing that. Now that was on EPO. Now let's talk about the faceted navigation, which is EMW's task. I love this little trick I'm going to play in you. So please, some of you know that already. What was that? Can someone tell me? Yaron, you certainly know this. I've seen that before. I guess most of the people in here would say this is sort of a rooftop, probably a building, whatever. What was that? I think everyone knows what this was. Well, it's the exact same thing. This is the Eiffel Tower from the top. This is the Eiffel Tower from the side. Here, your brain needs several loops to figure that out. You will figure it out at some point. But this, you've got a particular pattern recognizer in your brain that tells you what it is in a fraction of a second. So we want content to show itself in this way rather than in this way. This is the book way, this is the EPA way. Now, what's the essence? An EMW is literally markup at URLs. That's all there is. It is a structured externalization of ideas. So we externalize our knowledge, and we do that, we can do it in a structured way. And that's a very complicated way of saying it, but I just keep it as a reminder. It's a cascading grouping of factorized information, because a template instance is nothing else than factorized information. You've got key value pairs grouped under a template name. What do we need for that? Well, we need wiki text. And you should by now know that I'm a big fan of wiki text. And these are actually the only characters we need to express declarative knowledge. This does not involve functionality. For example, hash is missing for parser functions or other stuff. Now, is this new? No, it's not. It's probably 2,500 years old. People have always used character to actually express their information. Whether that is on a clay tablet or in a computer memory is completely irrelevant, right? Good. Now, how do we organize this? There is low-level organization, and we're going to talk later about high-level organization. The first one is the type role context model. Now, this is something that I developed myself because I wanted a clear-cut guideline about how to structure content or markup on a page. So typically, anything that we know of has exactly one type. For example, I am a person. Of course, I'm also a presenter now, but that is not a type, that's a role. So the role is assumed by the type, and it is in a certain context. I am a presenter at EMWCon 2017. I might be not a presenter at whatever, other conference. So there's a single type in software development terms, that's a singleton. There's only one instantiation of that template within one particular instance, and multiple roles. And here, this is something you find on my site that sort of visualizes that point. Then this is to show you how it's actually done. Of course, I'm making heavy use of the abstraction layer that was introduced by Cindy with the semantic titles. So I'm not naming things, right? This is all numerical. But you see that there's one component. So we're looking at the component 456123, which is one instance page. And it is there declared that it is of a particular component type, 511454. That is a company type, right? And it's got some context, it's got some keywords, whatever. So whatever is relevant within that context of being a type, you put in there. Then you see two instantiations of the role. You see this is now being, let's say it's a customer, right? This role 897180 is the role customer. So this company ABC assumes the role customer in the context of MITRE and in the context of data specs. Forget about the reification, we're getting to this. Then another line of organization there is keywording. Keywording is the only thing which is not semanticized by the system. It's only semanticized in your head. It's a string. The computer has no clue what you mean by that. It's only through the assignment as a property or within a template to an instance that it will say, okay, this is somehow keyworded in this way. And what you see down there is the keyword template, which is then assigned to every page that is actually named. The keyword pages are the only pages that I name revealing the exact string. Otherwise, it's a number. Then we've got actions. It's wonderful how this turns out. You know, you can do things to things, and things can do things. So, for example, you can invoice a company. So I want to have this as a terminological knowledge stored on the wiki, the fact that a company can be invoiced. And now you see, this is an instance. So again, 456123 is a company. It can be invoiced. And the fact that it can be invoiced is described with sub-objects. That's too complicated to explain now, but just the fact that we declare what we can do to things, or what things can actually do. Then, extremely important, irregular subject affinities. Subject affinities can usually be grouped within types or roles, or even contexts. So I have a certain height, I have an age, I have a gender. This is all type related. These are regular subject affinities. But it gets really interesting once you get to the irregular subject affinities. The way this is done, of course, you can see there the top. I could easily just paste a property onto that page, declaring is backed up to. However, I use an abstraction layer called relation, which again uses a sub-object. The reason why I use sub-objects so heavily, we'll get to that a little later. Now, very important, reification. We all know that the semantic web has a restriction in expressiveness, because it's binary, right? You have a subject, predicate, object. If you want to extend this to more dimensions, you need to reify. Reification is done, and this is something that I've been talking to about Yaron, who is very happy that he got rid of the property pages. But the reification paradigm actually makes heavy use of those property pages. So here, for example, we have a relation where you see is backed up. So that's the same one as this one. This is a non-reified, irregular subject affinity. Here we have it reified. Why? Because you can see that the reification 000060 is now an individual page representing the fact that whatever object can be backed up. And it opens a completely new room where I can accommodate new information about that relationship. That's what by the way, reification just means a thingization. You know, the industry was actually thinking about calling that thingization, but it sounds a little silly, so they came up with reification. So yeah, let's go on to there. I'm going to skip that. If we have time later, I can quickly show that to you. It's what I've done on my site in terms of visualization regarding these irregular subject affinities. But let's go on to the high-level organization. For the high-level organization, I use what is called the 3 ontologies method. Because when we are starting a wiki, we're like a painter with 2 million colors in front of a white canvas. You're completely overwhelmed with the dimensions of freedom you have to organize yourself. So in this book, Corporate Semantic Web, which is a Germany-based 2015 publication containing 22 articles that scientifically researched the extent and ways to which the semantic web is used in German companies. There's an article in there that suggests the following. We have a domain ontology. These are all the entities and properties and relationships that are unique to your particular domain. Then we have a task ontology that describes how we deal with the domain ontology. And we have a top-level ontology that merges or actually links those two ontologies together in order to make them useful. So we're going to quickly dig into that. Just one more remark. Of course, we can have all these parts stored on different wikis. So we can have a special task ontology wiki that we can reuse for many other wikis that contain the domain ontology. So what's a domain ontology? There's terminological parts. You've got domain-specific abstractions. You know, you might have not only types and roles, but certain types and certain roles. These go into the domain ontology as terminological. And of course, you've got everything that is assertional. So everything that is concrete in your domain goes into the domain ontology. Now, the task ontology contains a lot of things: dashboards, form systems, and so on. These are the things we need to keep the domain ontology clean and useful. There's a crowding out, getting really messy if we just let things out of hand. And the task ontology provides all the tools to do that. The top level ontology then contains all the generic and task agnostic EPO and EMW functionality. So for example, the type template would go into the top level ontology, because the type level, the type template is something we use no matter what we're dealing with and how we're dealing with it. Again, we're going to skip that quickly to pass on to this. So if we want to keep now this high level and low level organization clean and useful, what do we need? Well, you need the right templates in the right order. There's a little asterisk there, because if you use sub-objects, you can actually get rid of the second requirement, because the order of the templates do not matter anymore, because you completely separate the display of the data from the storage of the data. Then you need the right queries, right forms, right properties, links, and you need the right names, right? One of the large challenges in IT is naming things correctly. Now, let's say you have 4,000 pages that have an incorrect field name. You want to avoid the situations in a company where it says, well, this is actually that, but we never, took the hassle of changing it. This is bad, because there's mental overhead spent, and in the worst case, you're going to have a misunderstanding, and as I say in America, people could die, And you want coherence, right? Coherence means keep things together. Avoid duplication, reuse content, whatever. So, one thing I use, for example, to do that is what I call commented blueprints. So, you see this top call, wiki text 2 is a parser function. No, what is that? A key, how do you call that? It's not a parser function when it's with the key tab, magic tag word, whatever. The angle brackets, yeah. Well, whatever. So if you put that little line onto a page, it will show the template reification or the wiki text of that page. And you can comment it, and it's actually highlighting everything. And I'm doing this over a set of pages. So this is actually a poster of part of my ontology that allows me to quickly have an overview what I declared where and how, just as a tool to help me develop or engineer the ontology. Then we have, okay, now this gets slightly interesting. I need a way to extract part of the wiki. I want a particular facet, but I don't want to only do it by namespace, nor only by recent changes. So I wrote a tool that allows me to declare, let's say this is the connection to a wiki, wiki 1. So it's got the credentials for the API, and I can I instantiate a little basket of pages and say, get me all the pages being in namespace's property, and then from these property pages, give me all the pages that have the wiki text matching this regex. Then I open a second basket in a different, or it's actually the same wiki, but it's a second basket, template, and another wiki text regex match. And then I can create a third basket where I start off with the first two sets and say, well, now give me, of all these property pages and template pages, all the pages that have a page name part that matches a regex. And third, and that's getting more complex now, I can select then from all these second page, this third basket of pages, all the pages that have a field name in a template name matching a regex. So these are little methods in the public API of this tool that allow me to have a very fine-grained selection, fine-grained way of expressing what I need. And these are the methods I've developed so far for this purpose. Then I also wrote a part that allows me to rearrange wiki text on a page. Let's say I have 2,000 instance pages and I figured out that the template order is wrong. So again, I can use the tool I just talked about, the pages, this basket, and say set template order and add if not existent. Start with the component type and then add the component. So I can refactor a lot of pages to match the new, the improved way of organization. That is the way to, well, it's said in the title. Then we have the extraction tool for pages. I want to be able to extract wiki text into YAML pages, YAML files actually. And it should be the, those baskets, once you define the selection of pages, should be extracted into YAML pages, YAML files, which then can be put into a repository, let's say Git, for revision control. I don't want to integrate Git with MediaWiki because Git is the specialist for revision control and not necessarily for extracting or injecting the pages. Then let's skip that. This is something I wrote to compare sets of pages across wikis and automatic synchronization. Because when I develop, I clone the production wiki, I develop the content, and then I let this software telling me what I changed, and if everything worked, I will be able to upload it into the production wiki after it's been tested on a clone. And since we're pretty ahead, let's skip this. And very quickly about testing ontologies. As I said, I will first clone the system at the stroke of one key. So I've got a complete copy of a production system. I want to be able to formulate test cases in plain English. Now this is testing the end user functionality. And I need to be able to add test cases as cheaply as possible and run the test case permutations as cheaply as possible. Now this is just automating the testing of the user interaction, the end user interaction, which is very important when you do ontology engineering, especially regarding the task ontology. Good. Let's leave it at that. See whether you have questions. I hope it wasn't too complex and too quick, but we would have another 5 minutes.
I may have missed it, but what's the reason for putting everything into YAML format? What do you then do with that data?
The idea is when I want to extract a facet of a wiki, especially the templates and property pages, you know, the terminology. And then be able to either store that, version it, inject it into another one, or revision control it. And I want to be able, you know, we have this project with Mark where we are considering using a Git method to actually deal with this. What I not really like there is that you integrate Git with this functionality, and you know, good architecture maximizes the decisions not made. So maybe one day we'll use another tool than Git or a completely different approach. So we want to avoid that we too much tie in. And the easiest way for storing wiki text outside of the wiki would be a YAML or a JSON for that reason, but YAML, I prefer that in terms of readability. So that's why I chose that. It would also be, you know, possible to package up one facet and inject that into another wiki to provide that functionality, whatever is contained in there.
Lex, you mentioned that the reification, adding that extra abstraction layer lets you store that another information in that extra room that you mentioned. So what's an example of the type of information you would store there, or how would you use that ability?
Oh, you mean the reification?
Right.
If I want, let's say a company takes the role of a customer. So there, if in a simple system, on that company page, it would say, is customer, yes, or is customer off, and then you have this whatever object or whatever the company is a customer of. Of course, now, if you want to describe that relationship, you could create a sub-object and add a couple of properties into that sub-object that describes that original relationship. But that is limited. It's one dimension. And if you turn this sub-object into its own page, actually reification is nothing else than taking a sub-object and converting it into a page and maintaining the links. But reification is a term that comes from the semantic web paradigm, so I'd like to use it on this. But it's really making it rich, and you can have reifications of reifications of reifications, you know. Of course, the complexity grows. We can't deal with it, but we can program the tools that can deal with that. And then inference and all that becomes possible. Let me see. Where's the...
Just a little program note. Toby's going to present after lunch.
Exactly.
So,
after lunch.
Yes. So if you wanted to show your stuff for a few minutes, that's fine. And then we're going to take lunch and come back a little bit early from lunch so Toby can do both of his presentations after.
Where did Firefox go? Didn't we just install it? Oh, sorry. Yeah. It's, I'm on Linux since 10 years. Sorry for that. Yeah, I was talking about the 3 ontologies method, right? So this is on my site. I use exactly that model. So for example, the top level ontology contains categories, properties, and templates, which are completely agnostic to the domain and task at hand. So for example, component, component role, component type, keyword. And then of course like facet type, component type, semantic display title, and so on. And here we've got a couple of templates, as I said, component, component role, component type. So that's in the top level ontology. If we move down to the task ontology, now that's interesting because there's a lot of templates we use in the context of semantic MediaWiki or cargo that are not really templates in the way we think of them in the first place. But for example, a partial form template, or you have a display design template, or a data mapping template. So instead of having a big, the template namespace doesn't help me there. It's too big. It mixes up everything. So using or following this 3 ontologies method, I organize it in this way. And then here I have a complete, what is that? Task ontology auxiliary categories. Then of course the forms, partial form templates, data mapping templates, query result formats. As soon as you use the template format as a result format, you're going to be, even cascading templates. And that can be complex. If it grows too big, you lose overview. And that's not good. And then on the right, you've got the domain ontology, and that's, of course, all the the concrete types that are relevant to my domain, and a couple of properties that are unique to my domain. And then, let's see the... New tab. Yeah, let's take some time to load. Oh, another thing that you might appreciate is this. I set up an Elasticsearch server, and again, this is when you do ontology engineering, that, for example, shows me where I use parser functions. It's also for teaching stuff. So ask is used on this pages, tip info, section transclusion, site form link. This is of course very trivial. However, you have to set it up because you could do it. Could you do it? Replace text probably. Regex, the regex capability. But these are snapshots on an Elasticsearch server that keep an overview to what is used. And then even more interesting is this. This is the use of, where do I do semantization? And semantization, of course, always involves properties. So for example, let's take the property constitutes. This is part of the reification. So I have an overview where this property is specifying annotations. I have a list of where it is acting as a selector, and I have a list of pages where it is requested within query results. So again, these are facets that are valuable while you do the ontology engineering. And then remember, we were talking about terminology and assertions. What you see here is a directed graph representations of irregular subject affinities that I assert. So for example, the application's SMW syndicate hosts its source code on a repository. The domain, whatever Galaxy, makes use of an application. The website is hosted on a computer. Where we to go? Now here, oh, this is actually, you see a reification here, but it's broken on one end. But what's interesting, let's say you leave your workforce, you let it work for a couple of months and assert irregular subject affinities. At the end of these 3 months, you're able to ask your wiki, what are we doing? What's the terminology that we use? So as you see down here, let's say Galaxy makes use of Syndicate, which hosts its source code on a GitHub repository, is represented, what is it? The domain type domain, you see? The type domain makes use of a type application, which hosts its source code on a type repository, which is itself hosted on a computer, of course, which provides a web service. So you know, you can, if you can encourage your employees to assert irregular subject affinities, and they do that with a nice templating system and some optimized forms maybe, it could be very revealing what this method could come up with, and you could figure out, whoa, I never knew someone was hosting a repository on its mobile phone, right? It could be because he would assert it and choose those objects. So that's a tool I use a lot to develop, and then I think that's it. Yeah, let's leave that. Good, I guess you're all hungry, and thanks for the attention.